Measure of central tendency and mathematical and positional averages. Businesses collect a lot of data. Do you know what they need it for or how they use it? They usually use this data for planning and execution of operations. The data collected is analyzed to gain insights and take proper actions. You would have noticed that data is depicted in many executive reports diagrammatically along with summary measures. One of the summary measures is a measure of central tendency. So, what is a measure of central tendency? A measure of central tendency is an average of all values in a dataset. It is a single numerical value around which the data tends to cluster. It's used to give a summary measure. For instance, data of the output in a factory collected over a period of time is indicative of the production capacity of the factory. Now, it can be used even in a sport like baseball. The measure of central tendency will help you compare two batters based on the data sets collected. So, the average number of runs scored by the two batters can be compared to know the better player. As you can see, the measure of central tendency facilitates the comparison of data and helps in arriving at more informed decisions. There are two ways in which you can look at the measure of the central tendency of a dataset. You can either take its mathematical average or its positional average. The mathematical average of a data set is calculated by finding the sum of all the values in the data set and dividing it by the number of values in the data set. This is also known as the mean value. The positional average is derived by arranging the data points in ascending or descending order and identifying the value or data point that holds the middle position. This gives the median value. Let us understand this with an example. The heights of 5 people are as shown. The average height of these 5 people is calculated by adding the individual heights divided by the number of people, which is 180 plus 200 plus 150 plus 175 plus 190 by 5, which is equal to 179 centimeter. To find the positional value, arrange the set of values either in ascending or descending order. Then, identify the middlemost value, in this case is 180 centimeters. Mathematical averages work best when you have evenly distributed data. However, if you have a few highly disparate values in the data set, the mathematical average might not be a true representation of the data set. The positional average comes into play in such skewed data sets. Although mathematical averages are preferable, there are certain situations where positional averages can be used, like in the example of height that we just saw. There are different measures of central tendency. We will discuss them and their merits in the next video.